Hey everyone, in this lecture we will introduce the basic notions and notations on language theory that we will use during the course. An alphabet is a finite, non-empty set whose elements are called symbols. Usually we will denote the alphabet with the symbol sigma. As we know, this is the Greek symbol sigma, and although an alphabet is in fact any finite set, frequently its elements will be denoted by letters or digits. For instance, the alphabet AB is a possible example of an alphabet. In this case we have two elements, the element A and the element B. Now, given an alphabet, a word is a finite sequence of juxtaposed symbols from this alphabet. For instance, AB will be a word of this alphabet, formed by the symbol A and the symbol B. It will also be a word of this alphabet, for instance, the word BBB. It is a word of three elements of the symbol B. Another example could be just the word A. In this case, with a single symbol A, it is a word with length 1. Another example could be also the word B. And here the idea, and what is important to keep in mind and that the student should understand, is that on any alphabet we can always build the word with length 0. This word is commonly denoted by lambda, by this symbol lambda. And this is also called the empty word. This is the empty word lambda. And it is important to know that lambda, this empty word, this word of length 0, is not a symbol of the alphabet. So this symbol lambda is not a symbol of the alphabet. So it does not belong to this alphabet. In fact, lambda is a meta symbol that allows us to define the list of length 0. Following the idea of alphabets, we know common and famous alphabets. For example, there is the Latin alphabet of 26 symbols. For instance, here we have the Latin alphabet of 26 symbols from the symbol A that goes until the symbol Z. Another very common and known alphabet is the decimal alphabet. This is the alphabet that goes from the number 0 until the number 9. This will be another possible alphabet. Then we also have, for instance, the binary alphabet. The binary alphabet is another very famous alphabet, especially in the field of computing. And in this case, it only has two symbols, the symbol 0 and the symbol 1. And this is the binary alphabet. In words, we can also denote the length or cardinality of a word. In fact, the length of a word, now we will see how we denote it on the board, but it is basically the number of symbols that compose that word. In order to denote the length of a word, for instance, we want to know the cardinality or length of the word AB. Well, we represent it with these two vertical bars, with these two pipes around the word. In this case, what is the length of AB? Well, we just count the number of symbols. How many symbols compose this word? In this case, two symbols, the symbol A and the symbol B. So the length of this word is equal to 2. Now, what is the length of the word BBB? Well, we count the number of symbols and we see that it has a total of 3 symbols. We have 3 bits together. And so the length of this word is 3. As we see, it is very easy to compute the length of a word. The length of the word A is going to be equal to the length of the word B, which will be 1 because they both have only one symbol. Now the question, what is going to be the length of the empty word? So if we want to calculate the length of lambda, the length of the empty word, well, by definition, the length of lambda, the length of the empty word, is equal to 0. Since this word does not contain any symbol at all. Usually we are going to formalize words in this case with the symbols U, V, and W. Suppose and consider we have a very large word, for instance the word AB, with repeated B's 25 times, and then we can have A 30 times, and then finally AB, for instance. This is a very, very large word. Well, then we can assume that this word, for instance, is going to be U. And so whenever we want this word and we need to refer to this word, we can just refer to this word with the symbol U. So basically U is the symbol that represents this word. You can imagine this as variables that we assign to words. So commonly we use these three symbols to denote words. However, when we have more than 3 words, we will use other symbols as well to denote these other words. For instance, we can use the symbol X to denote the word AB, BA, or the symbol Y to denote the word BB, ABB, and so on. So basically we can pick any symbol we want to represent this word. In this case, if the word U is the word AABA, then when we compute the length of U, it is evident that this length is going to be 4, because we have 4 symbols in this word. Now, it is important to differentiate on one side the length of a given word. In this case, we have U and its length. And then, on the other side of the coin, we need to distinguish this from the notation of cardinality of a given set. On this course, we will represent the length of a given finite set in the following way. Let us suppose that we have a given finite set C, then the cardinality of this given finite set is going to be represented by these double vertical bars that we see in here. So to represent cardinality of sets, we use 2 vertical bars, these 2 pipes, but when we want to represent the length of a given word, we only use 1 at each side of the word. In the following lectures, we will see other fundamental aspects of alphabets and words in language theory. Specifically, just in the following lecture, we're going to study the occurrences of a given symbol in words and the operations between words.